homework? Because it didn't say.
What's that, Celine?
Did we have to do the dimension range for this one? Because it didn't
probably
say,
not. But
it only said,
I don't think you did, but if you see it later, so now you'll know how to find the domain and the range.
okay.
Okay, other questions on the piecewise 1 worksheet. Make sure your mic is up, or your mic is on. Remember, if you're asking a question, otherwise mic should be off.
What does the V mean?
The V?
Yeah, the V.
The V just means it's, yeah, that stands, V is for the point for the vertex. So it's the point where the graph turns on the absolute value graph, on the green graph. Okay, so anything else on piecewise 1?
I don't believe anybody else has questions.
Okay. So you guys had a chance to check your answers already, correct?
Yep, thank you so much.
Okay, we'll switch over to piecewise 2 then. Here, I think a better way to take attendance is just to, I'm just gonna copy all the participants that are here and then I'll figure it out later. Let's see. So I'm just gonna keep track of who's here right now. I think hopefully this works. No.
Mr. Morrison, this is
Yeah.
Do you think we're gonna go back? Like, in your opinion?
Are we gonna go where?
Back to school, in your opinion? Do you think we will?
I don't know for sure. I wouldn't be surprised either way.
There's other schools that are getting closed for the rest of the school year.
Mr. Morrison, I'm scared that I won't see you again until junior year.
That would be real, but you'll see me here virtually.
Well, like, yes, but I won't be able to say hello in person to you.
It's not the same. That's true. That will not.
You can just raid his house.
Okay, then Angel, are you here? I want to make sure everyone's here. So Angel and Devin, can you guys turn your cameras on?
I don't have a camera.
Oh, you don't have a camera. I should let me. Let's see here. You know, I have a better idea. I am going to just take a screenshot, a couple screenshots here.
Mr. Morrison?
Yeah.
Are we doing notes on PW3?
We are, yeah. But first I'm going to go over PW2.
Okay.
All right. Okay, so I'm going to switch over to PW2. Thank you again for your patience. We get this figured out. So it's a learning curve for all of us. So PW2, I think I'm just going to, it shouldn't take that long to go over this, and it's just the odds. So I'll probably just go through all these since I didn't give you the answers for the odds. And then I'll do a graph. So on number 1, so for this first one, it's going to make a V. This one has a vertex of 0, 0. Because my H is 0 and my K is 0. So I'm going to call it V for vertex. So it's going to go, but because it's a negative in front of the absolute value, it's going to be an upside down V. So it's going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So like this. And you could go like this, but you don't have to do the right side because you're only including the points that are less than -1. So locate the point on the graph where x is less than -1, and I can ignore all these other points. So this is going to look like this. This is actually only going to make a ray. It's not, it doesn't even show where it turns because it's only keeping the part of the graph to the left of -1. And then for this second graph, I'm going to do this in green.
Mr. Morrison, is it a V
Yeah.
if it's an absolute value function?
Yeah, it is a V, but it doesn't make it, because it's only for x is less than -1, so it doesn't make it to 0, 0. So it never actually turns.
Okay.
So the next one, I think you're going to see where it turns, because this one has a vertex of 0 is the h, -2 is the k. So 0, -2 is right here. And we're going to go down 1 into the left one. Do I fill this hole in?
Yes.
We do, because this one says or equal to -1. So I'm going to fill in the hole right here. I don't fill in the first one because it's strictly less than negative. So it's going to look like this here. And this one tells me to state the domain and the range. So the domain is all real numbers. So I'm going to write it like this.
Mr. Morrison,
Yes.
why is the V going down?
Because there's a oh, that's a good question. Okay. I will adjust that. See, Zoom is making the mistake now.
Is that a mistake, Mr.
So,
Morgan?
no, it's not. It's Zoom.
Mm-hmm.
Yep.
Oh,
Okay,
I'm back
so
and I'm here to call you out on your mistakes.
Oh, it was so nice on Monday. I didn't have to worry about that.
No,
Okay.
I'm back.
So we have 0, -2. And then this one, because it's +1, it's going to go up 1 over 1. And so I'm actually going to fill in this circle, because if you have a closed circle and an open circle on the same point, then you just keep it closed. The closed one dominates. So it's going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So like this. So silly Zoom. See, I had the perfect graph, but it changed it. You guys probably don't believe, and that's okay, because you'd be correct. So now the domain is still all real numbers.
Mr. Morrison, I have a question.
Yeah.
How come the wait, hold on a second. When we have an absolute value question, we have to, the first point that we put down is like, is the point when x is, I don't know what I'm saying.
Yeah, so the first point you can put down is just plug in the number that it's greater than or less than to find your point, and then start with that point.
Oh, okay, so since the red one is negative,
so you plug in, so I would plug in -1 into x to find the first point, and that'll give you a point -1. When you plug -1 in, you're going to get. Okay, someone needs to turn their mic off. You know who you are. You can hear the noise. Thank you. All right, so right here for the second point, you plug in -1. So absolute value of -1 is 1. When you subtract 2, you also get -1. So it's the same point for both. That's why they have that shared point in common. So just plug that. So you plug this number also in for x. That gives you the starting point for your piece.
Oh, okay, thank you.
Oh, is that Ethan with all the noise?
Yeah, sorry.
It's okay. You must have a crazy family.
I have questions,
Just
but
kidding. I'm gonna get in trouble now. What's that?
Do we need to state the vertex every time we do one of these?
You don't have to state it, but you should just know where it is for drawing your graph.
All right.
Okay, so I'm gonna do number 3 now. This was the only graph I believe on this homework. So any questions before I clear this?
Yeah, the range, Mr. Morrison.
No, the range. So that's gonna be, thank you. So that's gonna be also all real numbers, because this graph goes down forever and up forever and no gaps in the middle. So everyone's okay if I clear this out?
Yep.
Yep.
Yeah.
Okay. All right, so I'm gonna go to number 3 now. So here's, you don't have to do, the graph is already given to you. So I'm just gonna highlight the piece that I'm focusing on. So I'm gonna start with the green highlighter. So for this piece, I'm first gonna set up a piecewise function. You can call it whatever you want. I'm just gonna call it f of x. And then I'm gonna do one, this is called a brace. One brace, and you don't close it, you just open the brace. For a piecewise. Okay, so for this one here, if this kept going, so it's going down 1 over 1, down 1 over 1, down 1 over 1. Where would this, if it kept going, where would this hit the y-axis? What's the y-intercept of this line if it kept going?
-2.
Negative 3.
Negative
Okay.
3, right?
Oh, 3.
So I'm going to say this is, because the slope is -1, it's going down 1 over 1, down 1 over 1, down 1 over 1. It's going to be -1x, which I'll just write as -x. So it's m, I'm using mx plus b. So m is -1, b is -3. And then because this line is going to the left, I'm going to say less than. What's the x coordinate of this starting point?
-2.
-2.
Am I including -2 on this piece?
Yes.
Yes, so I say or equal to -2. So that's going to be my first piece. So now I am going to switch to blue highlighter. Focus on this one here. Okay, so for this one, here you can see what the slope is and see what the y-intercept is. So what's the slope here? What's the rise over run?
2.
2.
2, right? Isn't it up 2 over 1 from one point to the next? If you don't see it on the graph, you can always use that old formula. Do y2 minus y1 over x2 minus x1. Just pick any 2 points. It's always going to give you 2 for the slope. Or if you can see it on the graph, you're always going up 2 over 2. Or you could say up 4 over 2, or up 6 over 3, up 8 over 4. It always resimplifies the 2. So it's going to be 2x. What's the y-intercept of the blue highlighted line?
-1.
-1, good. So, and then this is going to start at this point right here. What's the x coordinate of that point?
-2.
-2. I'm going to say greater than -2. Do I include -2 on this? Nope, not for an open circle. So then I just have to state my domain and my range. So my domain is all the numbers. And for the range, it has a lowest point. So the y coordinate of this point?
-5.
-5. I don't have to mute everyone again. Okay, so -5 and it goes up forever. And I don't include -5. So all of this would be my answer.
Mr. Morrison, what did you get? What did you get the -1 from 2x?
The -1, that's just the y-intercept is -1.
Could you do number 9?
Yeah, I'm going to
Wait,
do
what?
all of them.
I'm still confused, Mr. Morrison.
And just look at the people with their mics on. Samir, Jacob, Ethan. You guys mind turning your mics off unless you're asking a question? Thank you. What's that, Ethan?
Yeah, so I'm still confused. Where'd you get the -1?
Right here, it's the y-intercept on the blue graph. That's your b for y equals mx plus b.
Oh, thank you.
So every line, I'm basing it off of y equals mx plus b.
Okay, thank you.
And then Mr. Morrison?
Yeah.
Where'd you get the -3 from -x minus 3?
Okay, so if this line kept going, it would have a y-intercept right here at -3. It doesn't go all the way to the y-axis, so you have to just extend it. So you just keep going down 1 over 1 until you get to the y-axis, so you know where the y-intercept is.
All right, thank you.
All right, so I'm going to clear this one out. We'll look at number 5. So this is good practice with graphing, seeing how it relates to piecewise functions. Okay, so I'm going to start by writing my piecewise function. Just to be different, I'll call this one g of x. Since I called the last one f of x, this is going to equal so for this first piece, a highlighter here, I'm going to do in green. So I'm going to use the formula for a parabola. So I'll do it up here. So for a parabola, you could think of it as y equals x minus h squared plus k. See how this parabola is going down? So because it's going down, you're going to have a negative in the front. That's what causes a reflection over the x-axis. So for this one here, it's going to be negative x minus h. So what's if you want to find the vertex of this point, that's my h and my k. So the vertex right here, isn't it 0, 4?
Yeah.
So everyone can see, hopefully, you can always let me know if you have a question, but hopefully everyone can see that the graph turns at the point 0, 4. So that's your h and your k. So if h is 0, you don't even need the parentheses because x minus 0 is just x. So it's just going to be negative x squared. And then plus k. Your plus k is plus 4. And here I'm going to say x, because this graph is going forever to the left, I'm going to say less than. And then look at the point where it starts. It starts right here where I circled. What's the x coordinate of that point?
Negative 2. Oh, sorry, 2. Sorry.
Positive 2. Do we include that point?
Yes.
Yes.
We do. So that should be the hard part of the problem. The next part is just a horizontal line, which should be easy. If this line kept going, what's its y-intercept?
5.
5. So this will just be, no matter what you plug in for x, y is just always 5. So this is for all values. Because it's going to the right, you say greater than. What's the x coordinate of the starting point?
2.
2.
2.
Do I include the starting point?
No.
No.
Nope. So that's going to be my function. I just need my domain and my range now. So for the domain, it looks like every x coordinate is represented. So my domain is all real numbers. I'm going to write it using interval notation. And then for my range, it goes down forever. And then it stops, there's a gap after 4. So it's going to go up to 4, and I'm including the vertex on the parabola, but then it jumps. See how there's a gap between 4 and 5?
Yeah.
So I'm also including on the horizontal line, so the u just means you're saying and I'm also including 5, and it doesn't go above 5. So I need brackets because I am including 5 in my range. So y can be any number between negative infinity and 4, including 4, and it can also be 5. So all of this here would be your answer.
Is it the same lady? Yeah.
When you do, does it matter the order? Like I have 4 minus x.
Yeah, 4 minus x squared is fine. But usually the one on the left goes on top. That's kind of the standard way to write it. The graph on the left would be the top one, but if you said 4 minus x squared, that's okay.
Mr. Morrison, why is the 4 inside of the parentheses?
Okay, you're gonna have to unmute yourself here. Okay, go ahead with your question.
Why is the 4 in the function k and 4 is k? Should it be on the outside?
Yeah, 4, there's no parentheses here, so the k is just, the plus 4 is separate. I didn't even need parentheses here because if h is 0, when you say x minus 0, it's just x, so you don't need the parentheses anymore. And then, so the k is automatically separated from the parentheses.
Oh, okay.
Mr. Morrison,
Yes.
how 5 is part of the range?
See how the blue highlighted line, doesn't every point on that graph have a y-coordinate of 5?
Oh, okay. Thank you.
You have to include 5. So the range is all the possible values that y can equal. So you have to include 5 there too.
Okay, thank you.
Uh-huh.
Mr. Morrison,
Yes.
when it's just like a straight line, would y just be like a single number?
Yeah, anytime it's a horizontal line, it's just going to be a single number, whatever the y-intercept of that line would be if it kept going.
Thank you.
Okay. All right, so I'm going to move to number 7 then. I'm going to clear this out. So we have 7, 9, 11. We're just writing the equation here. This is probably good practice, working with equations. Okay, so on number 7, I'm going to start with a green highlighter. So I'm going to focus on this one. So you can see, hopefully, both of these are parts of a parabola. So I'm going to use h of x equals, and then for a parabola, remember for both of these open up, so you don't have to worry about a negative. So it's just x minus h squared plus k. So for the one in green, the vertex is going to be 1, 0. So when I plug this in, let me draw my brace here. Oh, that was a nice brace. I'm proud of that one. Okay. So when I plug in 1 for h, it's going to be x minus 1, the quantity squared, and you don't have plus 0. So this is your hk. And so for the domain restriction, it's going to the left. So I say x is less than. And then what's the x coordinate of the starting point?
1.
1.
1. Thank you. Do we include 1?
No.
No.
Nope. So I move on to the next piece. So I'm going to use blue highlighter now. To the next piece I'm doing in blue. So for this one, the vertex of the blue graph where it turns. Can someone tell me the vertex of the blue graph, the blue highlighted?
2, 0.
2, 0. So the blue one turns at 2, 0. So now this is my HK. So I'm just going to plug this in the same formula. So it's going to be x minus 2 squared. And you don't, again, you don't have to write plus 0. So now it's going to the right of the starting point. So I'm going to say greater than. I am going to include the starting point. And then what's the x coordinate of my starting point?
1.
1. You probably notice it often picks up or off for both domain restrictions. Okay, so now I'm going to write the domain and the range. So domain is all real numbers because it goes forever to the left, forever to the right, including x, every x value in between. And then for the range, what's the lowest y coordinate on this graph?
0.
0. Do we include 0?
No.
No.
What about that point?
Oh, yeah.
Oh.
If it's included anywhere, you have to include it, even if it's not on the green piece. So I'm including 0, and it goes up forever. So I would say from 0 to infinity.
Mr. Morrison? So if it's on the left, for the green one, if it's on the left side, it'll always be less than 1, right? If it's going
to the left,
direction,
it's always less than. If the arrow is going to the right, it's always greater than.
and then if it's going...
If there's no arrows at all, then you write it like this. X is between two numbers when there's no arrows. Like on
then-
number 8, right here, I would say x is between -2 and 4, even though you don't have to do number 8. And then I would include 4.
Okay. And
so
then
if there's no arrows on either side, you have to write it's an in between.
Okay. Also, Mr. Morrison, if the arrow is going down, then it's less than 2, right?
It's not up or down. Up or down doesn't matter. It only matters if it's left or right, because it has to do with the domain along the x-axis.
So if it's going down to the left, it's less than, but if it's going down to the right, it's greater than.
Correct. Left is always less than, right is always greater than for your domain restriction.
Okay, thank you.
All right, so I'm going to clear out number 7. Okay, so number 9, we have 2 more. Figure might as well do all of them since it shouldn't take that long. And it's good practice. All right, so number 9.
Mr. Morrison, sorry to interrupt, but what's piecewise number 3 like? Is it like what we're doing?
It's applications of piecewise.
So like, are there any graphs?
Yeah, there's graphs.
Okay. Thank you.
Okay, so I'm going to call this one P of X just for fun. So this one, I'm going to split this up into 3 pieces. Oh, another good brace. Okay, so right here, I'm going to start with this one. So this would just be a line. So it's going to be based off of y equals mx plus b. Okay, so if this kept going, what would be the y-intercept of this line?
0.
What's the slope of this line?
X.
1.
Isn't it up 1 over 1 from any point to the next point? You're going up 1 over 1. Rise over run is 1 over 1. So it's 1x plus 0, which is just x. So that's 1x plus 0, simplified. For this one, the arrow is going to the left, so I say less than. And then what's the x coordinate of the starting point?
-2.
-2, good. Okay, now I'm going to focus on the other linear piece. Do this in blue. Okay, so right here, mx plus b again. What's the slope of this one? Looks parallel to the other one, so it should have the same slope. So it's also 1. What's the y-intercept here?
-3.
-3. So it's y equals 1x minus 3. I'm just going to write that as x minus 3. So this is an in-between problem. So the x coordinate of this point is -2. The x coordinate of this point is 4. I'm including both. Since I don't see a hole there. And for the last piece, I'm going to do it in yellow. Hopefully you can see this okay. So that's going to be a parabola. So the vertex here is this point right here. So that's 5, 0. And I'm going to be using y equals x minus h. It's positive because it's a happy parabola. It opens up, plus k. So if I'm plugging in 5 for h, it's going to be x minus 5 squared plus 0. You don't have to write. And the arrow is going to the right, so I say greater than. I already included 4, so I'm not going to include it this time. But if you did include it, that's fine. So what's the x coordinate of the starting point right here?
4.
4. I'd probably, if it were me, I would make one of these or equal to 4 from the blue or the yellow. Probably not both, but if you did both, you wouldn't be wrong. So I just need my domain and range. I should probably stop using yellow. It's a little harder to see. Okay, so for the domain, it's, whoa, I'm still using yellow. Thought I switched it. So the domain is all real numbers. I'm going to write it like this. And then for the range, it's going to be, it looks like it goes down forever and up forever, and no gaps in between. So -infinity to infinity.
Mr. Morrison,
Yes.
why isn't 4 included? Because you put x is greater than 4 instead of greater than or equal to, so I'm a little bit confused.
Yeah, if you include 4, that's fine. It's just I'd already included this point with the previous piece. So usually I wouldn't include it twice.
Oh, okay. That makes sense.
But if
Thank
you did include it again, that's fine. Because see how it shared, the blue and the yellow graph have the same point in common? So I already included the point with y equals x minus 3. I included 4. So I just decided not to include it again because it's not necessary the second time. Okay. Anything else on number 9 before we do the last one here?
For the first graph, why is that positive?
The first graph,
Yeah.
you mean the y equals x?
Yeah.
It's positive 1 because it's always going up 1 over 1. So it's positive 1 over positive 1. So your slope is 1 over 1, which equals 1. Anytime the graph is going up from left to right, it always has a positive slope.
I couldn't tell that was going up. I thought it was going down.
Oh, you read a graph like you read a book. You're going from left to right. So going from left to right, isn't it going up?
Yeah.
So yeah, don't look at the arrow. Look at from left to right, what is it doing?
Okay, that makes more sense.
Okay. Okay, I'm going to switch to the last problem on this homework, and then we'll go to the last lesson, which is piecewise 3. Oh, this one looks fun. Okay,
It's
so I'm going to do
exciting.
q of, it is exciting. So q of x. I'm just making up new function names. So
Mr. Morrison, your next one should be e of x.
E of x, it could be. But e has a different meaning, so I don't know why I would use e of x.
How about
So
d of x?
I could use d of x. That would work.
Yes.
From the OGD Swagmaster. Okay, so right here, I'm just gonna start with green. So that's a parabola. So probably a little quicker since we've done several parabolas. So the vertex here is -4, 0. That looks like it's, I mean, I guess it could technically keep going down, but I'm going to assume it's going to turn at -4, 0. So that means it's going to be x plus 4. It's always the opposite of the x coordinate, squared plus 0. So this is when x is less than, what's the x coordinate here?
-4.
-4.
-4, good.
-4. Wait, Mr. Morrison, isn't it a negative? Isn't there a negative x negative and then a negative in front of the x plus 4 squared?
Well, I'll give you the formula again. So it's y equals x minus h squared plus k. So whenever you do minus h, it always makes the opposite of that number. So minus -4 becomes plus 4.
No, I thought that since it's going up to the left that it has to be a negative.
Oh, that's only when the parabola is going down, is when it's negative in the front.
Oh, okay. Thank you.
Okay, so right here now, this is a line, so mx plus b. What's your m on this one?
-1.
Yeah.
-1. Isn't it going down 1 and then 1 to the right? So it's going to be -1x. What's the y-intercept here?
0.
0. So it's -1x plus 0. That simplifies to -x.
Yes.
And then this one's going to be an in-between problem because it doesn't have any arrows. So what's the x-coordinate of that point?
-4.
-4 and then 3.
And then 3. Good. All right. See how we're including both of them? Both endpoints?
Yes.
So for both of them, I'm going to say or equal to. Okay, now I'm going to focus on this one here. I'm not gonna lie, it's
coming.
pretty satisfying. Okay, so for the blue one, I'm gonna say if this kept going, it would go like this, like this, like this. So if this line kept going, what's the y-intercept here?
-2.
-2. What's the slope here?
Minus
One.
or
Minus
no, plus
1.
+1, right? It's going up 1 and right 1 to get from one point to the next. So it would be 1x minus 2. So I'm just going to say x minus 2. And because it's going to the right, I'm going to say greater than. And then what's the x coordinate of this point? Someone can count.
3.
3.
3.
3.
Tress.
All right, so here I'm going to say domain looks again to include every x value from -infinity to infinity. Does this graph have a lowest point?
Yes.
It has many.
It does. What's the y coordinate of the lowest point?
-3.
-3.
-3.
-3, and I'm going to include that. And see how it goes up forever and includes every point in between 3 and infinity? So I'm just going to say from -3 to infinity. So there's no gaps here where it doesn't have a y coordinate on one of the points. So that's it for piecewise 2. Any questions? Okay, I'm gonna clear this out and we're gonna do piecewise 3. Hopefully you have the notes, you're able to print them out. Okay, so piecewise 3.
Mr. Morrison,
Yep.
if we never come back, does that mean that we're gonna have to do all the trig notes on Zoom?
If we don't come back,
Yes.
yeah, then we would be doing trig notes on Zoom.
Oh.
Wait, okay. I know you kind of got rid of it. I'm sorry, but
Mm-hmm.
why is it that for like the range and stuff, why is it that sometimes you use the like a V because there's like another number, and then sometimes it's just like -3 infinity, even though there's like other points.
It's just if it like jumps, if it like there's space in between where there's no y values, if it like skips y values, then I have to split it up into different parts. Is that okay?
Oh, okay, I get it.
So yeah, anytime it includes somewhere, as long as somewhere it includes all the y values, you can include all the numbers. Okay, so
Got it.
okay, I'm sure I have that here. Okay, well, I'll just copy it. I could have sworn I had the PDF file to share, but I'll just do it on a blank screen. So hopefully you have the notes for piecewise 3. Okay, so here, the first one says f of x, so you should already have this on your notes. So this is going to equal, then it's big brace.
Mr. Morrison.
Yeah.
In a way, this is a blessing because I don't have the notes either.
Okay,
So
this works
I gotta
well
work
for
with you.
Okay, we'll be on the same page.
Exactly.
So if, then for the first one, it's if 0 is between, or if x is between 0 and 1, and then x. So bear with me. The good thing is these notes aren't that long. One side of one page. So then it goes 1, 2, 3, and then 1, 2, 3, 4. Okay, so when you draw the graph here, This is called a step function. It makes like stair steps when you graph it. So the graph is gonna look like this. So I'm gonna go up 1, 2, 3, 4, 5. I'm gonna go over 1, 2, 3, 4, 5. Is there no highlighter here? Not used to using this. Okay, so for this first one, it's equals 1 going from 0 to 1. So it's just, it shouldn't be anything new. It's just saying y equals 1 if you're going along the x-axis from 0 to 1. And then you would say y equals 2 if you're going along the x-axis from 1 to 2. Then y equals 3. So it would be up where y, it would be based off the line y equals 3. You're going along the x-axis from 2 to 3. And then lastly, y equals 4. You're going along the x-axis from 3 to 4. So from 3 to 4 here. So that would be your graph for that first example.
I like this.
Oh, I didn't color coordinate the rest of them. So this one was the yellow one, because I don't think this allows me to highlight that I know of. So this would be the blue one. Okay, the next two are just like this one. I mean, this is the main idea for the first three examples. I'm trying to see if there's anything special about those. It doesn't really look like it. Do you guys, maybe I'll give you a minute to try working on the next example, and then I'll give you like a minute head start, and then I'll just finish the next one, and I'll probably just skip the third one because that's probably overkill. So work on the next one. Make sure you can do a step function on your own.
Oh, Mr. Morrison?
60 seconds, and if you don't have it, Ethan, just bear with us for a minute. Yes.
Okay. Thank you.
You're okay? Mm-hmm.
Yes.
Okay, so I'm gonna do this first one. So it's saying y equals 4 if you're going from 0 to 2. So y equals 4 starts right here. I'm gonna include 0, and I'm not gonna include 2. So this is where x equals 2. So that would be the first piece. So it's y equals 4. You're moving along the x-axis from 0 to 2. Okay, for the next one, it's gonna be y equals 5 from 2 to 4. So I'm going to pick up where I left off at 2, and then I'm going to go over to 4 right here. And then for the last piece, it says y equals 6. So it's going to be the part of the line y equals 6 up high, going along the x-axis from 4, including 4, to 6, not including 6. So you'll have a nicer graph than I do because hopefully you're using the grids. But this should look like this should look like stair step. So this is called a step function. It's a type of piecewise function. Okay, so any questions on this one before we get to the last 2 problems?
Yes. Hold on a second.
Okay.
Well, like not really a question. It's just like my Wi-Fi like died on me, so then it was black and I couldn't see anything.
Mm-hmm.
Okay, hold on. Let me just copy this really quick.
You need to get better Wi-Fi. They don't pay your dad enough.
Wait, Mr. Morrison, I'm confused.
Yeah.
I'm confused with the red. How come? What did you go by for your graph, Mr. Morrison?
I just did. It's the line y equals 4. Isn't that a horizontal line that passes through 4?
Mm-hmm.
And then we're going from 0 to 2 along the x-axis.
Okay. Okay, so it's 4. So 2, 3, 4. Oh.
Okay, so I'm going to go to the Okay, so going to the last one here.
Thank you, Mr. Morrison, for being a great teacher.
You're welcome. Thank you for being a great student.
Yes.
All right, so this last one, I'm just going to summarize it. You can hopefully see the word problem, but you're working a summer job. So your hourly wage is $7. And then after, if you work overtime, that's greater than 40 hours. That means that's going to equal 1.5 times 7. So you're getting an X is 1.5 times your normal hourly wage. So 1.5 times 7. So that's going to equal, what would that be? That's 10.5. So that means if you work more than 7 hours, you're getting $10.50 an hour. So every hour you work past 7 hours. Okay, so for this one, I want to write a function here. So this is what's given to me. So I'm
Wait,
gonna write
Mr. Morrison?
Yeah.
Sorry to interrupt again, but what is that? Is that overtime greater than 40 hours?
Yeah, so every hour you work more than 40 hours, you get $10.50 per hour.
I think I might get one of those.
Oh, so wait, I'm confused. So like, if you work more than 40 hours, you get $10.50.
So for the first 40 hours you work, you're making $7 an hour. Every hour you work after 40 hours, you're making $10.50 per hour.
Oh, so at more than 40 hours, you're getting. Oh,
Yeah,
okay.
so if you work 42 hours, that means for 2 hours, you're getting paid a higher rate, $10.50 per hour.
Okay, thank you.
Uh-huh. Okay, so for this one, I'm going to write this as a piecewise function. So we're just looking at applications of piecewise functions. So your pay in terms of hours, so that's what P is. P is your pay. H is the number of hours you work. So you're getting 7 times H for the first 40 hours. Let me write this as a brace here. So it's going to be H is between 0 and 40. This one should be pretty straightforward. So you probably couldn't work 0 hours, but I'll just include it. And then I'm gonna include 40 hours. So up to 40 hours is full-time. Anything beyond 40 hours is considered overtime, and you get paid more for overtime hours. So if you wanna write a function that represents any hours you make beyond 40, what did you make? So for the first 40 hours, let's say for the first 40 hours, you're making, what would this be? So 10.5 times 45. Let's see here. H minus 40. Okay, so for this one, the first 40 hours, you're making $280. And then after that, you're making 10.5. Okay, so I'm gonna write it like this. I'm gonna do a little scratch work here. So let's just kind of get an idea for what we're doing. Beyond 40 hours, the first 40 hours, you're making, you're making $7 an hour. So it's gonna be 7 times 40. Wait, yeah, 7 times 40. And then you're adding to that 10.5 times the number of hours you make beyond 40. So how you write the number of hours you make beyond 40 is you would say H minus 40. So let's say you worked 50 hours. Isn't that 10 hours of overtime? Is everyone okay with that? 50 hours, that would be 10 hours of overtime, right?
Yeah.
So you do 50 minus 40 to give you 10. So H minus 40 tells you the number of overtime hours you're working. So this one's a little bit tricky, the setup. So I'm gonna simplify this here. So this is assuming you're working more than 40 hours. You'd be making $7 for the first 40 hours. For every hour after that, it's 10.5 times H minus 40. So you take H minus 40 again, represents your number of overtime hours. So if you work 100 hours in a week, you do 100 minus 40, so you have 60 overtime hours. So right, I'm going to simplify this. This is going to be 280. When you distribute the 10.5, you get 10.5H minus, that's going to be 4. Okay, so let me make sure, don't mess that up. 10.5 times 40. So it's going to be 420. So I'm going to subtract 420 here. And then when you simplify this, this is going to equal 10.5H. So 280 minus 420 becomes minus 140. So that's what I'm going to write over here. So this represents how much you're making in overtime. So you're doing 10.5.
Mr. Morrison, what'd you get for?
Where'd I get what?
What'd you get to? Did you do 40 times 10.5?
Yeah, 40 times 10.5 is 420. So this is greater than 40 function. Okay, if you want to draw this graph, so we're still on part A. So this is part A. So for the graph, I'm going to go by tens down here. So 10, 20, 30, 40, 50, 60. So this is going to be the hours worked. I'll say H. And this is going to be your pay. So maybe I'll go by 100 here. So 100, 200, Okay, so to graph this, so for this first one, I'm going to do this in green. So 7h, if you think of this as y equals 7x, it has a y-intercept of 0, and it goes up 7 over 1. You can also go up. So for the first 40 hours, if you were to plug 40 into 7, or 7h, 7 times 40 is 280. So 40 hours goes up to 280. So this is what my first piece is going to look like. You only need 2 points to make a line. So you're starting with 0, 0. If you work 0 hours, you don't make any money. And then if you work 40 hours, you plug in 40 into 7h. So 7 times 40, you've made $280. So this should be up 280 right here. So for the second piece, I'm going to do this in blue. So if you plug in 40 here, 10.5 times 40, that's going to give you the same thing. And then if you plug in a number like 60, so I'm just making up a number to find another point. So if I was to find P of 60, that's going to be 10.5 times, so you're working 60 hours minus 140, and I'm going to do that on my calculator. So 10.5 times 60. So if you worked 60 hours, you would make $490. That means it's working 60 hours, you're up here at 490. So see how the rate of change is faster? You're making more money each hour, so it's a steeper slope. So that is what you have to do for part A. So before I go to part B, any questions on part A?
Yes. How come you went off of
So for part B, it says how much will you get paid?
Mr. Morrison?
How come I went off of what?
How come you went off of the first point of 40 and 280? How come you went off of that? Like, you made another line off of it.
40 and 280, you said? Oh, this was 420. So then I just combined like terms. So 280 minus 420 is negative 140. Did that answer your question?
Oh, okay. Yeah.
Wait, so okay, the point where the green starts, is this supposed to be at 4350? Okay.
4350, you said?
Yeah.
So can you start the question over? Sorry, I think you cut out for a second.
Oh wait, 280.
Yeah, 280 is just the first or the first 40 hours. You're making $280. Then this right here represents how much you're making for overtime pay. So you're doing 10.5 times the number of hours you make beyond 40. So you write that as H minus 40. So if you work 70 hours, 70 minus 40, you'd be working 30 overtime hours. Okay, so part B should be pretty easy. It just says how much will you get paid if you work 45 hours? So for 45 hours, would I use the first piece or the second piece?
The second.
Second, because isn't 45 bigger than 40? So I'm just going to plug it into the second piece. So if you work 45 hours, you would do 10.5 times 45, but then you'd have to subtract 140. That's because of the work we did over here. So you just plug that into your calculator, and that's going to give you, so at 45 hours, you're going to make, so if you work 45 hours in a week, that tells you you're going to make $332.50 based off of our piecewise function. So that's all you have to do for part B.
Are those the notes, Mr. Morrison?
We just have one more problem to do, and then we'll be done.
Gotcha.
And the last one only has one part instead of two. Okay, so any questions before I clear this out?
Don't clear it yet. Don't clear it yet.
Okay.
I'm writing it down.
Yeah, neither am I. Yes, so am I. Don't clear it.
Okay. You guys hear me? Say yes if you can hear me.
Yeah.
Okay. Am I good to clear it?
Yes.
It just got really quiet. Okay, I'm clearing it now.
Okay, now.
Okay, so let's clear this out and let's go to the last one. So the last one says the math club is making t-shirts that say math rocks. So the t-shirt company charges $10 per shirt. So $10 per shirt for the first 75 shirts. And then they charge 100 for up to 150 shirts. They charge $7.50 a shirt. That's up to 150 shirts. And the last one, it's $5 per shirt. That's for greater than 150 shirts. So I'm going to convert this to a piecewise function. This should be easier than the last one, because the last one, see how it had different rates? Weren't you making more money for overtime than you were for the first 40 hours? So for this one, the rate is staying the same. So that means if you buy more than 75 shirts, you don't have to pay $10 for the first 75 shirts. You're paying the same price for every shirt. So as long as you buy, so it would be really stupid to buy, like, what would be stupid here? So if you were to buy 75 shirts, that would be stupid, because if you bought 76, you're going to be paying a lot less to buy 76 shirts than you would 75. So you might as well buy the 76 shirt, and you're going to be paying a lot less money than you would for 75 shirts. Does that make sense? Because every shirt is going to cost the same. So if you can buy between 75 and 150 shirts, you're paying $7.50 for all of those shirts. Does that make sense?
Yeah.
Okay,
Say
so
that
here,
again,
I'm
Mr.
going to call
Morrison.
this. So no matter what, you're paying the same price for all of the shirts. So if you're getting close to 75 shirts, you might as well buy up, like go to 76, because you're actually going to pay less overall, because no matter what, every shirt is going to cost the same. So if you buy less than 75 shirts or equal to 75 shirts, you're paying $10 for all of them. If you buy between 75 and 150, you're paying $7.50 for all of those shirts. So when I do a piecewise function, I'm going to say C for cost. So cost, based on the number of t-shirts, is going to equal. So it's going to be 10 times T. T is t-shirts. So maybe I'll say C is cost. T is number of t-shirts. So for you're paying $10 per shirt from 0 to 75 shirts. You're only paying $7.50 per shirt.
Mr. Morrison?
If you buy between 75 and 150, including 150. And then you're only paying $5 per shirt if you're buying more than 150. So if you're getting close to 75 or 150, you might as well exceed the number by 1 because you'll probably actually end up paying less. And sometimes it works out that way when you're purchasing a large quantity of something. They give you a better deal if you buy a lot of that item.
Mr. Morrison?
Yes.
Is it okay if we, for the 10t function, if we put like t is less than or equal to 75?
Yeah, I would also say greater than or equal to 0 because the number of t-shirts can't be negative.
Oh, true. Okay.
So I would just indicate to make sure that's clear that it's going to have to be a non-negative number.
Okay. Thank you.
Mr. Morrison?
Yes.
On our homework, will we ever get a problem that is different from the 2 that you've given us?
The homework should look pretty similar to the ones we just went over. Should either be a step problem or a similar word problem.
And then we do the odds, right?
No, for this one, you should do all of them.
Okay, thank you. Because I haven't. Okay.
I'll send out another message. I'll try to give something helpful, but this will be the last assignment until after spring break. And I don't think it'll take you that long.
Okay, thank you.
Mm-hmm.
Wait, this is the last assignment until after spring break?
So yeah, this assignment, you're doing all of them, but it's piecewise worksheet 3. So it's gonna be due tomorrow morning before 8 a.m. And then I'll send out something to have so you can check some of your answers, but try to do it before, make sure to do the problem on your own before you're checking it, because that's how you're gonna know if you understand it. And my plan is still, we have to be flexible because the plan can change, but my plan is still to give a quiz on this the week that we come back. So right now it's still scheduled for, I believe it's April 6th. So if something changes, you will be notified. So we'll see what happens. So just have to be prepared either way. So we're in challenging times. We need to be flexible.
So you're going to give it
for whatever comes our way. What's that?
Wait, the day we come back, Mr.
It wouldn't be
Morrison?
the day we come back, but it would be probably the week we come back.
Okay.
If we don't go back, would you give it to us online?
Give it to you online?
Yeah, if we don't go back to
I don't trust you guys
school.
that much.
How would you do it then?
I'll make it a group quiz for 6.
Yeah, our group quiz for 6th period, first period. 6th period is 2nd period.
Oh, Frankie's mic is off.
Hello, Mr. Morrison?
Yeah.
I have an important question. If we were not to go back to school for the remainder of the semester, how would we be able to get an A in the class if we don't already have one?
To get in the class?
An A in the class.
Oh. Well, attending all the Zoom sessions is a good start because you can get extra credit there. And there will be, we'll have to figure out other options if we come to that point. But right now, we just don't know.
And Mr. Morrison?
Yes.
Are we still, wait, so you said that piecewise 3 was the last assignment for spring break. What is this for?
Oh, that one's too hard to do online. So just maybe hang on to it just in case, but I'm not sure if we're going to get to that.
Okay.
So that's activity 8, right?
Yeah.
So just hang on to that for now, but there's a chance we might not end up doing it.
Okay.
Wait, Mr. Morrison?
Yes.
It says for the piecewise, the 7.5 is added.
The 7.5 is what?
The 7.5 T and the 5 are, instead of just those, it's 7.5 plus 187 point.
It's plus something?
What?
Yeah.
Where are you seeing that? Are you seeing that somewhere, or?
Yeah,
At the bottom of the notes.
on the bottom of the notes.
Let's see. Oh, maybe there's a. Let's see. So this isn't the last problem that I gave you, or it is?
It is, but the function just added up all the previous costs.
Okay, so maybe I had a follow-up where if you were to do the problem where it's like $10 for the first 75 shirts and then $7.50 for the next 75 and then $5 after that, that would change it. but when I'm reading it now, it looks like it's just based on the entire order. It's going to give you the same price per shirt, but it would change the problem if the first 75 shirts were always $10. That's kind of like the last one we did, where the first 40 hours you're always making $7, but then after 40 hours you're always making $10.50. So it's not like if you work 42 hours for the week, you're not making $10.50 for all 42 hours. You're only making $10.50 for the 2 hours after. So just make sure you can distinguish between the two types of problems. If the rate is changing at a certain threshold, like at 40 hours, after 40 hours, it's changing. But here, it's not, it's based on the entire order of t-shirts. So that's why I just left it like this.
Okay.
So yeah, what I'm looking at, what we have is okay. You might see something a little bit differently if I updated it.
Mr. Morrison?
Yeah.
How long do you think, my phone's almost dead, so how long do you think the session, do you think it'll be till 3?
We're just wrapping it up. Maybe I'll take attendance now, make sure everyone's paying attention rather than just go off the names. So make sure to have your microphone ready. I'm gonna start with the first period. I guess are there any other questions right now? Just general questions before I start this?
Are you gonna go over some of the homework for today? Because question on one of them.
If you have a question, you could stick around after. You can start working on that now while you wait to hear your name. But I will be sending you something where you can check some of your answers. So yeah, just keep an eye open for my Google post because at that point I can let you know exactly what to expect after spring break. But there's only one more thing you have to worry about this week is make sure you can turn in the Piecewise 3 worksheet. So any other questions before I take attendance? Okay, so it'd be a good idea to just kind of work on your assignment while I'm doing this because it might take me a good couple minutes or so. And then also, if you hear your name and you called your name, feel free to go. If you have other things to do, that's fine. But if you're just waiting, just keep working on Piecewise 3 assignment. Make sure your kid's on when I call your name. So I just want to make sure everyone's engaged rather than just going off of a list. Okay, so Jacob B. Here, okay. Jeffrey B. No Jeffrey? Okay, Natalie B.
Here. Oh, sorry, Mr. Morse. My move turned off. Trying to press space bar.
Okay, so I got Jeffrey. No Natalie? Okay, Nathaniel B.
Here. Here.
You're here, Nathaniel? Oh, I see Natalie. Okay, make sure your mics are turned on when I say your name. Okay, so I got everyone so far. So Vanessa C.
Here.
So you said here, Vanessa?
Yeah, I'm here.
Okay. Robert C.
I'm here.
Okay, thank you. Janelle D.
Here.
Here. Okay. Kayla D.
Here.
Okay. So Mohammed E. No Mohammed. Okay. Andre F.
Here.
Okay, thank you. Justin G.
Here.
Thank you. Sarah G.
Here.
Thank you. Calvin H.
Here.
Thank you. Benedict I.
Here.
Thank you. It's weird that I can't see you all. I can only see 4 at a time. It's kind of sad. Allison K.
Here.
Okay. Daphne K.
Here.
Okay. Isabella L.
Here.
Thank you. Jairus L.
Here.
Thank you. Gavin M.
Here.
Thank you. Ruben M.
Right here.
Okay. Devin M.
Here.
Okay. Carson M.
Here.
Thank you. Lena M.
Here.
Thank you. Sierra N.
Here.
Thank you. Jaylene O.
Here.
Thank you. Celeste P.
Here.
Thank you. Madison P.
Here.
Thank you. Kyle R.
Here.
Thank you. Ezekiel R.
Here.
Thank you. Frankie R.
Here.
Thank you. Caitlin S. P.
Here.
Thank you. Melana S.
Here.
Thank you. Audrey V.
Here.
Thank you. Lorenzo V.
Here.
Thank you. Ethan W.
Present.
Okay. Now 6th period.
Yeah, that's
Okay.
period.
So 6th period. Kyler A.
Here.
Thank you. Angelisa A.
Here.
Thank you. Joanna
Here.
A. Thank you. Angel B.
Here.
Thank you. Alora B.
Here.
Yay. Aviana B. Thank you. And then Olivia C.
Here. Good morning, Mr. Morrison.
Can't do it again. Good afternoon, Olivia.
Good morning.
Carol E. Thank you. Yasmin F. What happened?
So you have school. Could you check it out later?
Yeah, now I can check it later.
Okay, thank you.
Mhm.
Good morning. It's almost there.
Okay, Yasmin F. No Yasmin? Okay. Celine F.
Here.
Thank you. Heba H.
What do you mean? Dyslexia?
Is Heba? No Heba?